for our number sense routine. I'm going to set my timer for our number sense routine because I don't want to go over and miss the lesson because I'm talking about that. So let's talk about John, my friend John. He says that 0.2 is smaller than 0.20 because it has less digits. You see his thinking? What's he thinking? But John's wrong. I want you to think about why John is wrong and use your little grids there to kind of explain why he's wrong. Take about 20 seconds to privately think, just you, and then I'm going to have you talk to a partner. You ready? So think about why he's wrong. How could you use this little grid to show me he's wrong? 20 seconds, and then I'm going to let you talk. If you want to write on the back of it, you could. But you also can draw. Okay, I want you to turn and talk to the partner. You're kind of sitting right across, it looks like, for many partners. You have about 2 minutes left of our number sense routine. I want you to talk to your partner about what you're thinking. Why is John wrong? He's saying that this is smaller because it has less digits. That makes sense. If I have 18 and 118, 18 is smaller, 118 has more digits, it's bigger. But why is he wrong on this? Talk to your partner and use your grids, and I'm going to come by and ask you some questions. So what is that? 0.2? That's two tens. Somebody shows tens. Can you show me 2 tens? You shade those in. Shade those 2 tens. You just do it quickly. So it's going to be 2 of those. So if that's 2 tens, what's the other one? It's also 2 tens, but it looks different. But so we would say that number is not 2, because that's 2 tens. This one is 20, 21. Right? And that 20 represents 21. Oh, so can you shake those in and explain why it's wrong? Oh, yeah. Yeah, all you gotta do is take away 2. Okay, so let's come back together and talk about some things you were thinking there. Do you mind if I borrow this? And I'm going to show you, hopefully, is the Elmo up? There it is, or the ladybug, excuse me. So, some of you were saying he was in, I heard this, it's the same. How many of your partner groups said that it's the same? So, who wants to tell me why it's the same? I don't understand. How can it possibly be the same? Those numbers look totally different. What do you think?
Because the 0 doesn't matter.
Oh, the 0 doesn't matter. Oh, that's the end of our number sense, but we'll finish up our conversation. So, what do you mean the 0 doesn't matter?
The 0 doesn't have a number, so it doesn't stand for anything.
Okay. So it doesn't stand for anything, I heard. What do y'all think? Who can say more? Give me more details. What does she mean by that? Look at this picture, maybe this will help. Look at what this person shaded. See what they shaded here? And you see what they shaded here? Turn and tell your partner which one is which, and how would you say these? Turn and tell your partner.
You heard this one.
Maybe you can take this even from 0.
Okay, so come back to me. What did you and your partner talk about? Which one's which? Yeah. Go ahead. So this one is tenths. How does she know that's tenths, y'all? Yeah, how does she know? Okay, 0.2 is 2 is in the tenths place. Then how does she know this picture was tenths? Go ahead, you can say it. Oh, either one. There's 10 of them, right? It's a hole. So there was our hole at the top. This one had been cut into tenths. So if this one is 2 tenths, what's the other one? Yeah. 20 hundredths is what you told me when I was at your desk. I know it's like all these words get all jumbled. And you were telling me they were the same. All of y'all were saying it's the same. But they are set differently because this one is 2 and 2 tenths, and this one is 20 hundredths. So when we say the 0 doesn't matter, I get what you're saying. But that 0 does matter because that number's not 2. That number's what? 20. But tell me again, why are they the same? Who can tell me why they're the same? Yeah, go ahead, honey.
Hey, Alvin, can you call us?
Oh, great. So she's saying they're both shaded identical. If I put them on top of each other, would they be covering the same amount of space? They would. Last thing I'm going to tell you for number sense while I turn my computer back to the PowerPoint. Turn and tell your neighbor, how many hundredths are in 1/10? How could that for you? Turn and tell your neighbor that. Oh. Okay, who can tell me? What'd your partner say? How many hundredths are in a 10? 10. So if I have 1/10, how many hundredths do I have? 10. If I have 2 tenths, how many hundredths do I have? 20, right? What if I had 3 tenths? 30 hundredths. So they're the same because they represent the same amount, right? Not because the 0 doesn't matter, because it does kind of matter because there are 20 of them, right? All right, so let's get into our lesson for the day. You can kind of throw that off to the side. So this is what we're going to be learning today. Yeah, math is fun. I'm all excited. I'm excited. Here we go. I know I can use what I know about single-digit multiplication. Do y'all know some stuff about single-digit multiplication? Like 6 times 5 and 4 times 3? That's what I mean by single-digit multiplication. You know some stuff about that. I know you do. And so you're going to use what you know about that to help you solve larger multiplication problems. Because in 5th grade, we solve some larger problems, don't we? And here's how you're going to know you're successful. These are the things you have to do to show me you're successful. You will have to create a model of what I'm asking you to show me and explain the connection. So when I come back, I'm going to be, okay, well, how's this connected to this? How's this smaller number connected to this larger number? And you got to explain that to me. And I also want you to be able to model it. So model and explain. Y'all with me? Awesome. So Halloween's coming up.
Yeah.
All right. So Ms. Wilkerson, she's been out shopping. She has found some erasers that she might want to buy for the students. And she's found 3 bags of these cute erasers. They kind of look like this. At Walmart, there were only 6 erasers in every bag. Y'all with me? So 3 bags, 6 in every one. I need to know how many erasers would that be if she bought, and that should say 3. I'm going to go fix that right now. If she bought those 3 bags. So you and your partners get together. You're going to work for about 3 minutes on, remember our success criteria, model and explain. We're using what we know about single to help us with larger. Okay? So work with your partner. Use your chips to show me how many erasers she would have if she bought 3 bags with 6 in each one. Ready? Talk with your partner. Whoever the groups were. I know Ms. Epps said y'all talked about what your groups were going to be before I got in here. So go ahead and turn with your partner. You'll have to get up or turn your chair so you can see the manipulatives and tell them what to do. Whoever has these. Yeah, you guys work together. What do you know about? Three. And how many are each back? 6. So how did she model that with these chips? 6 1. She says that. She says 6 1. Why does she need 6 1? What's that going to show? It's going to show one of the backs, right? So one back would be 6 1. So y'all, right? Agree? So when we got to work together, how could you show the other 3 backs? What would that look like? Make a model. All right, guys, y'all got your stuff? Okay. All right, so Tell me here, look at our groups. Why are you drawing three groups? What does that represent? The bags, you agree? How many are you gonna put in each one? 6. Could you show that with your mom? Remember, you have to explain why that shows it, so be able to explain. Now look at this, what's he putting in there? 100, a 10, a 10. What do these chips represent? Yeah, so if this is 10, are we putting 10 erasers in each bag? No, how many are we putting in each bag? Only ones, all right, y'all work on that one. All right, what do y'all coming up with back here? What you got? So there's 3 bags, you agree? So there, how many, is that the number of groups or the size of the group? The 3. She says the size, y'all agree? She said, oh, I don't know. Why is it the number of groups? Why are you changing it? Oh, okay, so there's 3 bags. So the bags are the groups. So how could you show me with the models 3 groups? Okay, so she spread them out. Now help her. She has the manipulatives. Tell, what should she put in each one? Talk to your partner. What would that be? And what would that look like in an equation? Go ahead and talk about that. All right, tell me about your model here. So he has 3 bags with 6 in each. Did y'all make that with your chips back there too? So which, on this model, where are the bags? What would be the bags? Okay, point to them. That's 1 bag, 2 bags, 3 bags, right? And so why did you write 6 times 3?
Because there is 8 bags and 6 in each.
And 6 in each, right? And so when you were looking at the 3, was it the number of groups or the size of the groups? The number of groups. How does he know that? How does he know that the number, that 3 is the number of groups? Because there's 3 bags. Awesome. Okay. Oh, so I need you to come back with me. So remember, our target for today is to use what we know about single-digit multiplication to help us solve larger problems. Y'all remember that target? And so I wanted you to look at a couple things. Let's make sure we're all clear on what we know before we start solving larger problems. Okay? Let me pull this Elmo back up. Excuse me, ladybug, whatever it is. I'm going to put this one under here first. And y'all see that? Got it. Okay. So look at that, guys. I want you to talk to the person sitting next to you, that partner again, and talk about what's represented here. What are those squares? What does that represent? What do those little ones represent? Go ahead and talk to your partner. What does that Okay, so come back to me. What's represented up here? Tell me, what does this mean? What are these? These squares, what do they represent? Yeah.
The bag.
The bags. Would y'all agree? So is that the number of groups or size of the group? I heard size. Prove it. Number. Prove it. How can you prove it? Which one is it?
Number.
I'm hearing number. I'm hearing size. Which one is it?
Number.
It's the number of groups because why?
Because the size of the group is 6.
The size of the group is 6. But in the problem, what was the size of the group? Remember what we were buying? Bags of what? Erasers. And how many were in each bag? 6. So we had 3 bags, which are 3 groups. So the number of groups was 3. That was our number of bags. And the size of the group was how many erasers were in each one. Do y'all agree? Got it? Okay, so then, where was that other? I stole from you. Did I lay it down? Well, it has kind of the same thing, but somebody drew a picture, so I want you to at least see a pictorial case when you're modeling here in a minute. You want to use a picture. So this person drew pictures. Oh, and I forgot to ask you, why did the person who put the chips in there choose the chip with a 1 on it? What does that 1 represent? Yeah. The erasers. 1 eraser, right? There were 3 groups and there were 6 erasers in each one. So I want you to keep that in mind. You said the number of groups was the bags, correct? And the size of the group was how many erasers were in each one. So here's part 2, because remember our success criteria today is to connect what we know about those single digits to the larger digits. So now here comes the larger digits. Are you ready? So part 2 of this is, okay, then Miss Wilkerson, she's like, that's not enough. I'm going to have to buy 1,000,000 bags. So she went to Sam's, and guess what they had? They had bags of 60 erasers and bags of 600 erasers. Now she can buy it for the whole day if you're at school, right? By the way, she's not really buying that. I'm making it up. But it'd be fun, wouldn't it? So she's buying 60 bags of 60 and there's bags of 600. If she buys 3 bags of 60, how many will she have? And we didn't even talk about how many. Y'all told me you had 6 times 3 is 18. You had 18 ones, right? 18 erasers is what you all had showed me. Now we want to figure out how many she's going to have now. So remember, part of your success criteria is to explain how what you had in front of you connects to this. So as you're talking with your partners for the next 6 or 7 minutes, I want you to model it, but I also want you to explain how is that model like this model, and how is it different? Are y'all with me? So I want you to model this out. What if she buys 3 bags of 600 and 3 bags of 60? There'll be 2 different models on your desk. You can leave the other model if you want and add another model. Totally up to you, but you have about 5 or 6 minutes to work with your group to model this out. Show me what that looks like with the model. And how do you know that so quickly? What are they doing over here, y'all? Why are they pulling out these chips? The 100. So why do you think they had? How many are there? That way. There's 6. 6. Oh, represent 600. So why do you think they have 3 of these? So remember, part of our success criteria is how is that like the last problem? Talk to your partner about how this is like the last problem, and can you show me in an equation how those 2 things are alike? Talk to your partners. What is this? How is it same from last? And then you show me that in an equation. All right, what do you guys got going on? You're working on it. So tell me what you're thinking as you're working on it. There's going to be 3 groups still. What makes her think there's still 3 groups? It says the problem. The 3 groups. It doesn't say groups, but the groups are what? The bags. So it didn't change the number of bags she's buying, did it? So the number of groups didn't change, but what is changing? The size of the group. So how big is one group now? 60. So have we got 60 yet? Not yet. Still trying to find them. Hopefully there's enough in there. If not, you know, we can always draw pictures. But I think we have some extras. Y'all need some extras. They're in a different color, but it doesn't matter. Right? So here's some tissues for yellow. So what would the total be? So before it was 6 times 3 is 18. Is that what y'all had? So what would the total be now? Yeah. So you had 6 times 3. Like Kylie has 6 times 3 is 18 because we had 3 groups of 6. And now it's 180. But what's the equation look like? I want y'all to work on what does the equation look like and compare it. How does it connect it to the last equation? Okay. What you guys coming up with over here?
It's compared because it's
How did this
Okay, so tell me, remember part of our success criteria was to connect it to the first one, to single digits. So what's the connection here? How are they the same?
6 times 3 equals 18, just like this one. But there's actually a 10. You have 1 or 0.
Okay, so let me ask you a question. What stayed the same in the 2 different problems? So what he said the answer stayed the same. Y'all agree? How's the answer the same? Oh, did you hear what he said? It's still 18. So here we had 6 times 3 is 18, but the chip size was what? 18 what? Remember your first one? What size was the chip? 1. So could you write 1s up there just so we can keep track? this was 18 once. So did you hear what he said? He said these are still 18. Is he right? Is there still 18 in these? But now what size are the chips? So would our equation be the same? So, okay.
60.
So is it 60? Oh yeah, 60. You're saying 60 times 3 because we had 60 groups. But what's another way to say 60? 6 tens. Could y'all write that for me over here? 6 tens times 3. Could y'all write that for me so I can see what that looks like? So it's still 18. What changed then? Right. So use these terms. Number of groups or size of the group. What changed? The size. Y'all agree with that? So work on that equation about how these equations are similar but a little bit different. Use the words tens and hundreds in your equation. Okay? I'll be back to you in a minute. All right, tell me what's happening over here.
But it changed from ones to hundreds.
Okay, what changed from ones to hundreds? Okay, so the number of groups changed or the size of the groups changed? Would y'all agree with that? So the size of the group went from, what size was it before? 6. What was the size of this group? 600. Are y'all with me? So what does the equation look like? I see you've written that. You wrote 3 times 600, right? What was the first equation?
Remember the first one was 3 times 6 equals 18.
Okay, so 3 times 6, but it was 6 what chips? What size was the chips? Ones. This is 3 times 6. Y'all only have 6. You don't have 600. Or do you? So why is there only 6 here and you're telling me it's 600?
Because
It's what? They're all hundreds, right? Y'all agree with that? So it's 3 groups of 6. We could say even the word hundred. Where before you had 3 groups of 6 ones, 3 groups of 6 hundreds, and this one would be 3 groups of what? 6 tens. So I want y'all to think about what that equation might look like. Could you write the 600 and the tens in a different way than this, using like the name of the place value? Talk about what that would look like. What was the same? What was the same about all the both equations?
They have the same
Same amount of what? Oh, got 45 seconds. And we're going to share. Same what? What was the same about this equation and, or this model and this model? Your tens model and your hundreds model. What's the same? So let's just look at his over here. You see he has the tens and he has the hundreds. So this is all one model and this is all one model. What's the same between this model and this model? Number of groups or size of the group? Yeah, number of groups. You have one group of 60, 2 groups of 60, and 3 groups of 60. You have one group of what? 2 groups, 3 groups. So what was the same in both the models? The groups are the same. It's always 3. But what changed was the number or the size of the group, right? But it looks like there's still 6 in each one. So I'm confused. How can the size be different if you have 6 in every one of them? Talk to your partner about what am I talking about there? What do I mean by if there's 6 in each one, how is the size different? Talk to your partner.
600.
Why is it 600?
Yeah, all right.
Yeah, because we're looking at what we know about multiplication. From small numbers to larger numbers. Yeah. And there was one more group I asked to write it in words. You. Oh, okay. So you pulled that out. So it's 6 groups. So you wrote 100. Is it 180 tens? Do we have 180 tens, or how many tens do we have?
No.
How many tens do you have here total? There's 180 total, but how many 10s do you have? If I counted every single one of them, there would be how many 10s? 6 here. Well, there should be 6 here. We're missing one. And then 6 here. So how many total 10s, y'all, are there? If we counted them. 6 here, 6 here, and 6 here. So how many 10s chips is that? Check my figures. 18. So is it 180 10s or is it 18 10s? Okay. All right. So let me borrow this if you don't mind. Let's come back together. I love how you all work together to make your models. You did an excellent job. So now let's share out some solutions so that we can get to our target for the day, which was to make sense of and connect single-digit multiplication to larger multiplication. Have you found some of those similarities? Some things that are the same as you're exploring? Did y'all find anything that was the same? Yeah, I know you did because I was walking around and I talked to you. So we're going to share some of those things that we found that are the same. Are you ready? Okay, so let's look at a couple of models. So I just want to refresh our memory of this model. Remember this one? We had 3 groups of 6 ones. Remember that? And it was 18. So now let's look at this model. Here. I'm going to try to freeze this. Maybe you can get where you can actually see it. Maybe you can see it there. And the pink chips, they have a 10 on them. It's kind of hard to see, isn't it? They have 10s. It's hard to see, but I promise you it really does. So I want you to talk to that neighbor again. And I want you to talk about what's represented here in this model with the pink chips that have a 10 on them that I know is really hard to see. And how is it the same and different than the model that we saw at the beginning? So talk to your partner. Talk to your partner. What's the same? What's different? So what was the same? The total is still what? How is the total? I'm with you. Okay. I think. Okay, so let's come back together. Let's look at this model. And you guys were talking about what was the same and what was different. So let's start with the same. What was the same as the first model? Yeah.
Well, there were 3 bags, and the second model, there's still 3 bags.
Did y'all hear that? First model, it was 3 bags. This model, is there still 3 bags? So the number of groups did not change, did it? So what was different? Yeah. I added a 0, she said. What did she mean by that? Yeah. Add a 0 to the what? What did she add a 0 to? But she's saying I added a 0. What did I add a 0 to? So the first one we had, remember it was 6 ones. Y'all remember that? So what did I add a 0 to? What is she saying I added 0 to? The 1. So instead of 6 ones, this became 6 what?
10s.
10s. So here's what I want you to talk about to your partner now. Is the product the same? Or is the product different? Because if they're both 6, shouldn't the product be the same? Turn to talk to your partner. Is the product the same or is it different? And why? Okay, so what do y'all think? Is the product the same or different? Who agrees it's the same? One person? And 2 people say it's the same, and everybody else thinks it's different. So let's hear it. Get listed in. Why do you think? It's still 18, he said. Y'all agree that it's still 18? Except the first one is 18 what? Ones, and the second one is 18 tens. So it's not just adding a 0. That 0 means something, right? But they're tens now and not ones. It's like if I go to the store and I give the clerk, he says, you owe me $9.50, and I give him a $1 bill. And I say, oh, it's the same, just add a 0. He's not gonna like that, is he? He's supposed to give me a $10 bill. You can't just add a 0. It means something, right? So looking at this equation, I want you to take a peek at that. So do you see this equation at the top that says 60 plus 60 plus 60? And then the one that says 6 times 3 is 18 ones and 6 times 3 is 18 tens. So when we remember our success criteria today was to be able to explain the connection to smaller digit multiplication to larger. Are they pretty similar? Yeah, it's just the size of the group is changing a little bit, right? So if you see that equation there, and I think our friend, tell me your name, honey. Joshua, his group, worked on that second equation. That really shows how they're the same, doesn't it? That it's 18 and 18, just the size of the group change. So we talked about the tens and ones. Last one I want us to look at is the other one. So we have our 3 bags of 60. What about the other one that Miss Wilkerson could buy? Remember that one? Is it going to be different? Let's look at a model for that one. Can y'all see that? It's a little crooked. So let's see if she can do a better job. Okay, so let's look at that one. So remember, thinking about what's same, what's different. What's the same, what's different? Talk to your partner. Okay, so it's still 18, but it's not 18 ones. All you're doing right now is y'all agree with that? So if I know that 6 times 3 is 18, do I know 6 times 30? It's still 18, but it's 18 ones. Yeah, I think that's if I had 6 times 30, then I had 6 times 30. 30 times 300. Can I do 30 times 6? Talk to me about how. How can I use what I know about 6 times 30? 30 times 6. Oops. Oh no, it went away. Oops. All right, so let's come back together. Last discussion to end our lesson for today. So once I get the picture back up there, sorry about that. Was it the same? Was it different? What did y'all talk about? Who wants to share what your group decided? Yeah, right here, sweetheart.
The same.
Oh, what time is going on?
Size of the like there was like the number of the bags. The difference with the size of the bags.
Oh, did y'all hear that? I love the way she's using her language there, her math language. She said what was the same was the number of bags, right, honey? Isn't that what you said? She said the number of bags was still what? 3, but the size changed, right? Yeah. Would you agree with that? But wait, I'm confused. I still see 18 chips, y'all. The first one was 18. The second one was 18. The third one was 18. But y'all are telling me they're all different answers. But I see 18 every time. Trying to tell your partner why I see 18 every time. But it's not just adding there because you can talk about the action versus not looking at that pattern. Because then you can use your small multiplication to help you. Awesome. Okay, come back together. So help me. I'm confused. stay that way, I feel like. That if they're all 18s, but the answers are different? Huh? I'm confused. Help me, Joshua.
They're basically the same still because they just add, like, the last one just 0, but just another 0.
So our friend, tell me your name, sweetie. Andre said the same thing when I was talking to him. He said, if you're just adding zeros, Miss Lovelace, right? If I know 6 times 3 is 18, 6 times 30 is just add a 0, 6 times 300 is just add a 0. But I'm gonna argue with you for just a minute, because you're not just adding zeros. What does that adding of zeros actually mean you're doing? Yeah. It's a pattern. It definitely is a pattern. But what about, what did you notice in your size of your groups? What was it? You are. But what about these chips? Does this represent 1?
It represents
10, right? So it's 6 tens or 6 hundreds. So when we looked at that one equation that said 6 times 3 is 18 ones, 6 times 3 is 18 tens, 6 times 3 6 times 300 is 1800s or whatever we looked at. I forgot how we looked at it. It was 600. So it's not just adding a 0. It's because those chips are worth more, right? They're worth more. So it's still 18, but the total is 18 100 chips, not 18 10 chips, not 18 1 chips. So with our target for the day, we were supposed to connect what we know to small single digits to larger numbers. Did we do that? Yeah. Did you find the connection?
Yeah.
Tell your partner, what was the connection that you discovered today while I get your A certificate. If you don't mind, put your chips up.
That was the
Okay, so what did you and your partner talk about? What was the connection? It was always what? Yeah, go ahead. Whoever wants to share. Yeah, go ahead. 18 tens or 1800s. Do y'all agree with that? Yeah, so if you know 6 times 3, do you know a lot of other stuff? You know, we knew 6 times 3 was 18. Do you know 6 times, or 3 times 6 tens, or 60? Yeah, because it's just 18 tens now. Now it's 1800s. What if it was thousands? We didn't do thousands today, but what if it was 3 times 6,000? Would it still be 18? Yeah, but it would be 18 what? What if it was 10,000? Doesn't matter, right? 6 times 3 is still going to be 18 groups. It's just the size of that group got a little bit bigger each time. Instead of 1 chip, we use tens, hundreds, whatever. So your exit ticket there is exactly what we talked about in our lesson today. If you would fill that out or solve the problem, explain how 9 times 5 and how knowing that 9 times 5, how will that help you solve 9 times 50 and 9 times 500? I want to hear and see you write on this the words groups and size of the group when you're explaining. You can draw a model, but I also want a sentence that says something about what you know about the size of the group and the number of groups, okay? So y'all work on that. Thank you so much for letting me come in your room today. I enjoyed it thoroughly. You guys are awesome.